Hello, and welcome to the video on evaluating the limit as x approaches a numerical value of a rational expression that is in indeterminate form, and then by simplifying. So when we're looking at this limit question, I have the limit as x approaches -2 of x to the third plus 8 over x squared minus x minus 6. Now, in doing these problems, the very first thing you want to do is you want to see what's happening with the denominator as x approaches that value. If the denominator approaches a numerical value that's not 0, we can just use simplification we can just use substitution to get that. If, however, my denominator approaches 0, then I need to look at what's happening in the numerator and then see if there's common factors that can be removed. So let's look. Here, the limit as x approaches -2. Well, as x approaches -2, x squared approaches 4, and x approaches -2. So I have something approaching 4 minus something that's approaching -2, and then minus 6. So that would be 4, then minus a -2 is +2. So 4 plus 2 is 6, minus 6 gives me a 0 in the denominator. Now, let's see what's happening in the numerator. As x approaches -2 for my numerator, something approaching -2 cubed approaches -8, and then plus 8, that gives me a 0 in my numerator as well. So this is 0 over 0, which is called an indeterminate form. When we have that type of an expression, we need to investigate it a little bit closer to see what's really going on. Now, with a polynomial divided by a polynomial, I can actually look at the factorization of the numerator and the denominator. Because if a number run through a polynomial gives me 0 out, x minus that number is a factor. So since -2 run through the numerator gives me a 0 out, x minus -2 or x plus 2 is a factor. And -2 through the x's in the denominator did the same thing. It gave me 0 out. So I know that x plus 2 is also a factor in the denominator. But I do still need to find the remaining factors. Well, let's investigate the factorization of that x cubed plus 8 in the numerator. I can use synthetic division in order to find the other factor. So I will take synthetic division and I will divide with the -2. And remember, in synthetic division, you just use the numerical coefficients in front of the terms. So the numerical coefficient in front of x cubed is 1. There's no x squared, so the numerical coefficient in front of the x squared is 0. The numerical coefficient in front of x is 0. And then I have my constant term 8. Now with synthetic division, we bring that first number down, so 1 comes down. And then we multiply that -2 times that 1, so -2 times 1 is -2, and we bring it up underneath the next number. And then we add. 0 plus -2 is -2. Then we start over again. We multiply. -2 times -2 gives me 4, and 0 plus 4 gives me 4. And then we multiply. -2 times 4 gives me -8, and then we add. 8 plus -8 is 0. And we knew we were going to get that 0 because -2 run through the polynomial gave me a 0 out. So my factors are x minus that -2, that x plus 2 that we already wrote down, and then the remaining factor is in descending order. My power of my numerator was power 3, but I factored out an x to the first. So I'm going to have an x squared term, and its first coefficient is a 1, so I have 1x squared. Then I have minus 2x, and then plus 4. So that x squared minus 2x plus 4 is the other factor of the numerator. And specifically, this example we wanted to do is a video because x cubed plus 8 isn't the easiest thing to factor, and it's nice to know that we can get that other factor using synthetic division. Now for the denominator, we could use synthetic division, but it's a much easier expression to find the other factor. I need an x squared as my first term, so x times x is how I would get that x squared. I need a negative 6 as my last term, and positive 2 times negative 3 is how I would get that negative 6. And if you just double check with your outers and your inners, you'd have a negative 3x combined with a positive 2x would give you that negative x in the middle. Now that we have it factored, we can remove the common factor pairs, and we're really just looking at the limit as x approaches negative 2 of that remaining factor x squared minus 2x plus 4 over x minus 3. And limits are as you get infinitely close to negative 2, not what's happening right at negative 2. And that's why we can evaluate this simplified function to get our limit. So now as we put in negative 2 for the x, looking in the denominator first, I see that that is negative 2 minus 3, which gives me negative 5 down there. I don't get a 0 in the denominator anymore. So I can continue the process of plugging in the negative 2 for the x's throughout the expression in the numerator as well. So I have that quantity negative 2 squared minus 2 times the negative 2, and then plus the 4. So that gives me 4 plus 4 plus 4 in the numerator over a negative 5 in the denominator. And 4 plus 4 plus 4 gives me 12 in the numerator, and I get negative 5 in the denominator. Now that doesn't simplify anymore, so I have the result that the limit as x approaches negative 2 of x cubed plus 8 over x squared minus x minus 6 is equal to negative 12/5.